Hello YouTube, this is a video on SolidWorks Static Simulation. So let's start. So first take part, new part, sketch, change the unit to millimeter, go on top plane, click on sketch, choose center rectangle, then give dimension. So keep the upper dimension 100, the length to be 150. Okay, now click on features, extrude. On the direction one, keep blind 200 and direction 2, keep 300. Okay. So see, this block has been created. Now click onto this face, click on sketch. Again, choose a center rectangle. Now here, no need to specify dimension. You can take it according to yourself. Okay. This is just to visualize. Select this arrow, pull it outward. Pull it outward according to you. Okay. So this much is, I think, is enough. I think it should have been a little less. So just go on to edit. Yeah, this much is enough. Okay. So this is what the geometry on which we are going to perform static simulation. So what is static simulation? Static simulation is the one in which the force that we apply onto a material, it does not change with time. Okay, it is constant, it remains constant with time. So if this is the part that we are going to make in real life of, and we have multiple materials from which we can select whichever material we want. Now, what are the chances that given the condition of the force that we are going to apply, this part is going to sustain that force? Okay, so one option is to create multiple these kinds of part in real life and to perform the force analysis, but that will cost a lot of money. So the second option is to use the software, and there you can virtually make the part and apply the force and calculate the results. So after, at the end of the static simulation, what we'll get is we get the stress generated, the displacement, maximum displacement, the factor of safety, and the strain analysis. Okay, then we can change the material type if we want, if the results are not safe, and if they are safe, then it's okay for us, then we can manufacture this part in real life. Okay, so how to on the simulation? Go on to SolidWorks add-in, click on simulation tab. It will take 2 to 3 seconds for the simulation tab to come here. So see, the simulation tab has came. Click onto the simulation tab, go on to the new study. Here we are choosing static. Okay, for now don't tick onto the use 2D simplification. I will explain this at the end of the video. Okay, so just click right. So the first step of the simulation is to apply the materials. So you can apply the material by right clicking over here, or you can also apply the material from the upper features. Okay, upper these icons from here. I prefer to do it from here. So see, if you go on to apply edit material, there is a list of all the materials. Okay, there is a list of steel, iron, aluminum, copper. Okay, there is wood, rubber, silicon, carbon fiber, plastics. So there is a lot of materials which are in the library of the SolidWorks which you can use, and you can also add custom materials if you want. Okay, but for now what I'm going to apply is I'm going to apply a plain carbon steel. Okay, which is here. Connections are given only when there are multiple geometries. Okay, now as the geometry is merged in itself, this is a single part, there is no need of connection. I have already made a video on dynamic simulation. There I have applied connections. Okay, just before this video I have made the dynamic simulation video, so there you can see. The second important step is to apply fixture. Go on to fixed geometry. Okay, so now what we are going to do is we are going to apply force on this face. But now if we apply force on this face, this geometry will turn over itself, so the force will not be calculated, the stress is generated. So for that we'll have to first apply fixture. So I will select this face. Okay, and here I will click OK. So see, the fixture are applied this onto this face, so this face is not going to move from its position. Okay, and the symbol of the fixture is these green arrows. Now what I will do is I will click on to right click, I will click onto the force I'm going to apply onto this face. Okay, direction you can change from here, and here you can change the value. I'm going to apply 5000. Okay, you can also change the units if you want. Okay, I'm choosing SI unit. So see, we have applied force, we have applied fixed support. Now the next thing that we need to do is just to create a mesh. Now see, if you go with the finer mesh, it will create a fine mesh. Okay, meshes with very small element sizes. That will increase the quality of your result, the accuracy of result, but it will increase the pressure on your system, and also the result calculation will take more time. So that's according to your preference. For now, I am going with the middle only. Okay. So see, the meshes have been created. Okay. And the last option is to just click on run the study. So these results can also be calculated by using paper pen, okay, by conventional methods, by solving the CAE formulas. But for solving such a simple sum also, it takes about 1 hour to calculate the results, okay, of stress, strain, displacement, reaction forces. But with software, you can do this at a very high space, at a very high speed. Okay. So see, they are giving you stress, displacement, and strain generated. So what is the displacement? Now see here, the displacement they are showing um, into 10 raised to form, right? 4.2 into 10 raised to minus 2. Now if you want to see this into floating number, how you can visualize? Just right click on it, go on to the chart option, and here they are showing it into scientific form. So click it onto floating. Okay. So see the maximum stress, that the maximum displacement when we are applying force here, the body is going to deform downward, and the maximum deformation, which is in the form of displacement, is going to take place at this end point, which is 0.04 mm, which is very less, right? 0.04 mm is what means it's not even 1% of 1 mm. So this body is absolutely safe. That means the plain carbon steel material is strong enough to withstand 5000 kilonewton of 5000 newton of force. But then the question arises that why it is showing this much of deformation over here. This is because the software is helping us to visualize the deformation. Okay. So how you can see that how it has increased the scale. This scale, it has increased to over 1300 times of the normal scale for us to visualize it properly. So if I want to visualize this deformation at the normal scale, that is 1 is to 1 scale, how we can visualize? I will just click on this deformed result. Okay. So see, right? So now it is showing the, here also now it is showing the deformation, but because it is 0.04, we cannot see it. Okay. And then the another reason why they increase the deformation scale to this much is because there is option to animate also. So if I click on to deformed result, and now if I click on to animate, so because I have increased the scale, I can visualize the direction of the force, the animation. Okay. You can also change the scale. You can go to edit definition, and from here also you can change the true scale, that is 1 is to 1, or you can keep it on automatic. Okay. Now another way, so from the displacement itself, we are able to visualize that this material is good enough to handle this kind of force. The second thing, the scientific term, which is able to tell us whether the geometry is safe or not, is called factor of safety. Okay, so if the value of the factor of safety is above 1 or 1.5, then the material is safe to withstand the given force. Okay. So how you can visualize the factor of safety? Just right click onto the result and click on define factor of safety plot. Click on OK. So see, the factor of safety for this is found to be 32. So for this material, given that we are applying 5000 Newton of force, the factor of safety is found to be 32. Now, suppose if I increase the force from, wait, I will just explain the split line first. Okay. So see, I will explain the animate option also. See, if you right click on it, if you click on animation, so this is the animation that is it is showing. Now you can see the animation is a little bit laggy because it is showing at 5 frames per second. So you can increase the frames. If you click here 40 frames, again click on to play, so it will recalculate all the frames and increase the speed. Okay, so see, it has increased the speed accordingly, right? Now if this force that we have applied, it has spread equally onto the entire surface, but if I want to apply this force at the end point, at the end of this part, how can I apply the force? Because if I go on to the force, then I can only select the entire surface, right? This face is unite. I cannot select a part of this face. So if I want to use the part of this face, I will have to use split line. So for that, you will have to go on to the model view. Here, you will have to create a sketch. Okay. So I will just make a vertical line, select, and then you will go to features and here use split line. Choose this face. So see, based on this line, they have created a face over here. Now this face I can select to apply the force. So I will have to just delete here. So I deleted the force. So this face, now I'm going to apply the force. Okay. The same quantity of force I'm going to apply. So again go to force, click on this face and choose 5000. And now I can just rerun the calculation. Okay. And it will regenerate the result. Now, when the force was equally spread over the region, over all the face, that time the factor of safety was 32. But now, because the force is at the end point, the stresses has increased and the factor of safety has gone down to 18. Okay. So this is how, based on your condition, it's calculated the results and the results are changed. Before the displacement was 0.03. Now the displacement is 0.09. So even the displacement has increased a little bit. Okay. Now if suppose I increase the force, now it is 5000. Suppose I increase it to one more zero to 50,000 and again recalculate. Now let's see what result. Okay. See, now the factor of safety is reduced to 1.8. So this is the maximum stress that this material and this geometry can handle, right? If you change the material, again the results will change. Okay, for example, if you change the material to cast alloy steel and let's run the study. And now if you see the factor of safety, see the factor of safety is increased to 1.9, which was 1.8 for the alloy steel. Okay, for malleable cast iron, for this the factor of safety is 2.2. So this is how, based on the force that you are applying, based on the fixed support that you are applying, and based on the material that you are applying, the results can change. Okay, so now the important options that we need to see is, see the mm. In case of the malleable cast iron is 1 mm. Okay, which was before 0.0 to 0.03. It is now 1 mm. So this material is a little bit less strong as compared to that of the plain carbon steel. Okay, so I have shown you what is the animate option. I've shown you AD definition is for applying the scale, chart option is for applying the, see one more option there is in the chart option, that is to show the maximum and the minimum annotation. So here, what is the maximum and minimum annotation you can see. So see, this is the maximum displacement, this is the minimum displacement. So this is also important option. The next is section clipping. So see, section clipping is that about a section you can cut the part to visualize it properly. Okay. Next option is ISO clipping. ISO clipping is that you can specify a value. For here, the value is specified to be 0.5 mm and it will show the results which are above the 0.5 mm. So for example, I don't want the green part, I want only the yellow and red part. So here, if I see yellow part, the value is 0.831. So I will change here 0.831. Okay. And see, click on to OK. And see, it is showing only the yellow and red part over here. So this is how it works. Okay. Okay. So now, if I change the geometry, even if I change the geometry, the stresses will change. Okay. So for example, here if I go here, if I click on front plane, sketch, here if I click like this, this, go to feature, go to extrude. I will extrude about the mid plane and take 50 for example, or let's take 75. All right. And again go to static study. Again I will have to rerun the study. Okay. See, before the deformation, here it was a red mark, right? Now, because I have applied the support at bottom, the red mark has gone. The factor of safety has also increased to 5.5, which was before 2.2. So if you change the geometry also, then the factor of safety and all the results are going to change. Okay. So this is a very handy tool, right? Now, the next option is to generate a report. So suppose I want to now I have performed all the simulation. Now I want to give the presentation on this simulation. So how I can give? I will have to take all the screenshots. I will have to take all the material. You can also see the material details. Okay, like what is the material type, what is Poisson ratio, shear modulus, mass density, tensile strength, yield strength. This all I will have to input into the Word file. But SolidWorks can also generate a report for you. So just click onto the report. Okay, here you can give the designer name, company, logo, address. Okay, you can also choose the paper size, and here you can choose what information you want to mention, and just click on to publish. So it will generate the Word file for you. So it will do all the hard work for you. Okay, it will also take the screenshots. You will also not have to take any screenshots. So see, it has created the Word file. Okay, so see, it is showing the model information. What is the model? It has also calculated the mass, the volume, density, and weight of the model. How? Because we specified the material, right? So based on that material, it already has the weight properties of that material, and based on the dimensions of the geometry, it has calculated the mass, volume, density. Okay, so you will also not have to calculate the mass density. It will calculate for you. It is also showing information about the unit system, the model. So what kind of material that we have used? We have used malleable cast iron. All the properties are shown below. What were the fixture? What was the load? Okay, and based on that, see, this is the mesh information. What was the mesh size? What was the element size? Okay, and based on that, what is the results? So this is stress result, strain result, right? Displacement, factor of safety. So this result is good enough for any kind of presentation. Okay, so I will also make a video on the torque application. Okay, torque, which is in case of shaft, or in case of spur gear, or sprocket. Okay, so that is also very important to calculate. So here, if you drop down, see, these are all the forces that you can apply. These are all the parameters that you can apply in the static simulation: force, torque, pressure, gravity, centrifugal force, bearing load. Okay, temperature, flow. So this all comes under the static simulation. And what are the different types of simulations that we can perform? So if you click on to new study, you can see there is static, frequency, topology, design, thermal, buckling, fatigue, nonlinear, linear dynamic, drop test, pressure vessel design. So these all kinds of simulation you can perform. So this is this is a very advanced software. I have already made a video on the nonlinear simulation. Okay, so the next that I will make a video, I will make it on to the torque analysis. So this is all about the static simulation. Okay, our one part is left. I was going to explain what is the 2D simplification. So just click on new study. So before, we did not tick on to the use 2D simplification. Now we will use 2D simplification. So just tick on to the 2D simplification. So what is 2D simplification? So suppose this geometry. This geometry is symmetric over the front plane, right? This geometry is symmetric over the front plane. It is a square kind of geometry. So instead of performing the analysis onto the entire 3D part, which increases our number of element, which increases our uh, modulation time also, right? We can convert this geometry into 2D geometry, and then later on we can perform results onto that geometry, and we can scale the results over the 3D part. Okay, so just click onto the 2D simplification, click here. This geometry is symmetric over which plane? Over the front plane. So see, it has created a non-thickness geometry, and the thickness of the geometry was 100. Click OK. So see, this is a non-thickness geometry, right? Now onto this geometry we can apply material. Let me apply plain carbon steel. Okay, I will change this again to malleable cast iron. Let me apply fixture. Go to fixed geometry, select this face. Okay, let me apply force. Select this face. Select 51 to 3. Okay, 50,000. Let me apply mesh. Now this time, before I created a coarse mesh, right? This time I will create a finer mesh because I have 2D geometry, right? So now the time will be same and the results will be more accurate. So this is the use of 2D simplification. Okay. So see, I've created a very fine mesh. And now last option is run the study. Okay. And just click on chart option. Click on the floating number. See, 0.3 mm is the displacement that is taken. To visualize factor of safety, right click, define factor of safety. Right, factor of safety is found to be 3.6. Okay, but now this, if I want to scale this onto the 3D, how can I do? Just right click and click here, show as 3D plot. So see, this is the entire geometry. Got it? And this shows. So this is all about the static simulation. I hope you like the video. You understood how to perform static simulation. So thanks for watching, whoever watched till end. Thanks a lot, and stay tuned. I will upload new videos. The next video will be on the uh, torque application or torque simulation. Okay, thanks for watching. Thanks a lot.